So, using circle theorems to find angles subtended. So what that means is this word subtended, it's basically another word for created. Alright, so if I cross lines, I create angles. If I have a circle and I draw chords across a circle, if I draw more than one, I create angles. Okay, so that word subtended means that. Okay? And there's a couple of bits of vocab we need to learn, like produced and things like that, means something in circle theorems. So unfortunately, to start with, what we're going to do is we're just going to write a few circle theorems down. But you've said you've started this, you'll remember some of them. Yeah? So remember, the whole point is that we use these circle theorems to calculate an angle. All right? So you are going to have to remember them. So I'll tell you what you need to do. Find the circle. Why don't you draw a few circles? Right? So draw a few in your book, and in that way, and give a bit of space for a bit of explanation around it, and then we don't have to keep stopping for you to draw another circle. So let's start with four circles, okay, and then we'll come back to it. Okay guys, so first couple of circle theorems. So I've drawn the start. Now what I've done is I've started at a point A, right? And there's a second point B. And what I've done is I've gone up to another point, let's say P, and then back to B. And that has created an angle.
Why P?
I've just gone from one point to another point to another one. All of them on the circumference of the circle. And it's created an angle. Are you happy with the creating an angle there? Yeah?
Yeah.
Right. Do you remember the circle theorem for this one? Can you remember it?
Make a line to A to B.
Pardon?
Make a line A to B.
Yeah, but do you know what the rule is? So I've created one angle. Anyone remember? You've not seen this one before. Right, basically what I've done then is I've gone from a point to another, so 3 points. Now the circle theorem, the rule is that if I go from the same starting point to the same finish point, if I go to a different point here, right, I do it like that, or I do it over here. So I always start at A, finish at B, but maybe I go to point Q, I get another angle. Or I go to point R, I get another angle. Any idea what the circle theorem states?
The third line, they're all same to A to B.
The length of the line?
Yeah, here.
That line.
Yeah, the third line is 8.
Right. The line, it's got nothing to do with the line. Do you remember with the objective? What did I say in the objective? It's all about finding angles. Okay.
They are same degree.
They're what?
Same degree.
Yes. So these three angles are all the same. Right? Now, I just want to point one thing out. This is quite important in that if I were to draw a line through A and B, just draw one line like that, okay, I cut the circle into two sectors, okay? So one here, this side, and one this side. And the rule is, any angle in the same sector is always equal if I go from the same two starting points. Alright? Make sense? Yeah, no? So I know the angle P, Q, R, they're always going to be the same. Alright? Now that's the same. You don't necessarily have to draw this again, just to show you that if I cut my circle into two segments again, alright, that would then be, this would be A, point A, this would be point B. If I choose a point P, point Q, point R, I create angles, alright? So I go from A to that point there, that creates an angle now. If I go up there, it creates another angle.
Oh God.
If I go over there, I create another angle. Same diagram. So that angle, this angle, that angle are all the same. So that's the circle theorem. Alright? Now, just to show you, if, however, I change to this side, but I still go A to B, what do you think about that angle? Is it the same or is it different?
That's different.
It's different because it's a different side of that green line. However, if I do the same thing here, what can you say about all the blue angles?
They're all the same.
They're all the same. So it depends which side of the line you're on. Alright?
Do we copy
So,
that?
well, remember I said it's on the video, so I think as long as we've got this first one, we can write down, say, angles in the same sector are equal. That's what we need to remember. Okay. And do you know what? It doesn't matter which points. So I could actually use this the other side, and I could start, if you like, at Q. Go from Q to R. So using the same diagram, if I went Q, A, R, this would now be the angle, and it would be the same as the angle Q, B, R. That angle is also the same. Alright, so you've got two sides to it. Right? So it's about starting and finishing at the same point, so it doesn't have to be the same side. Important one. Yeah? Okay with that?
Mm-hmm.
Right. Now we're following on with the same thing. Alright, so we're following on with the same one. This time, if A and B are at either end of the diameter of the circle, right? So we've cut the circle into two semicircles. So we've got two semicircles. So it's different. Instead of the green line being somewhere else, I could actually show you by changing that. So the black one is now a green one that goes directly through the centre of the circle. So do you know what the O represents? O for
The middle of the circle.
Yeah, do you know what O stands for?
Theta.
Or no, it stands for origin. O for origin. Because that's where you start the circle from. From the middle, you draw your... Right, okay. So it goes through the middle of the circle. Now we have the same sort of idea, only this time, if I go from A to B up here, alright, so if I did that somewhere else, we know what? What do we know about those two angles? They are the same, okay? But I actually know something else as well, because it's in a semicircle. Right. What I also know, only if it's in a semicircle, but what does that angle look like actually?
90 degrees.
90 degrees. And you should find, if you've drawn a proper circle, and you've gone straight through the middle of yours, the angle that you draw will be 90 degrees. Okay? So hopefully this works. So yeah, this angle are actually 90 degrees. So we can say angles in a semicircle are 90 degrees. Okay? Okay with that one?
Yeah.
Right, I'm going to follow on from this one, but use the same principle. So I want you to understand a lot of these are linked. So, do you remember here we did one side, they're all the same, the other side, they're all different. But if I have a semicircle, they're both the same. Yeah? So up here, that's 90 degrees. This is also 90 degrees. What if I did one the other side? So I think you've already told me that. So if I do this, that angle is also 90 degrees. Okay. Now, I'm going to draw this. Don't do it just yet yourself. Right, so I'm going to set the same thing up again. So here is, just get that right, that's my semicircle. This time, I'm going to draw from there to there. What angle's that?
90.
90. I'm going to do one the other side, anywhere I like. What angle's the red one?
90.
90. Right. This time, which I'm just going to delete this. Okay. Right. What I have now is a particular shape. Right. This shape, if I go back over just in black, any ideas what it might be called? Definitely not. No,
Diamond. Kite.
it's not actually, because the sides are not the same.
Oh.
You're not likely to get it, but just in case you had heard it, this is actually called a cyclic quadrilateral.
That was my second guess.
That was your second guess. I thought it might be. Cyclic meaning within the circle. So as long as the four corners, the four vertices of the quadrilateral are on the circle, the circumference of the circle, we have what's called a cyclic quadrilateral.
So hard.
Now, the rule about a cyclic quadrilateral. Now, did you remember? So don't draw yet. You can draw in a second. If you just listen up, right? Do you remember? It was created like that, yeah. Two semicircles. Right. What do I know about this angle?
It's 90.
This one's 90. And if I go opposite, what's this one?
It's 90.
It's 90. And what do you notice about 90 and 90? They make
880.
180. Now, what do you think about this angle and this angle? What do you think?
They are plus together equal to 180.
Exactly. We don't know what they are, but here's the rule. And you can see how it follows on from what we know. That opposite angles in a cyclic quadrilateral add up to 180 degrees. So if I add them together, they equal 180 degrees. So it's not always going to be 90. So for instance, could I take something here and make a cyclic quadrilateral?
Yes.
So if let's say I deleted this one. Delete that one, delete that, delete that, delete that. What shape have I got?
The same as the other one.
So it's called a
Cyclic.
cyclic quadrilateral, and this angle here and this angle
It's
here
180.
add up to 180 again. Even if they're not 90 and 90, opposite angles add up to 180. Okay? So we'll just write in a cyclic quadrilateral, opposite angles equal 180 degrees. Okay?
Can we draw?
Yeah, you can write that down. Okay, drawing that. I need to draw another circle, so I shall do that. The next one we're going to do, when you're ready, is again, we need to know the centre of the circle, again at the origin. Okay, that's not theta, that's no. This time, pick 2 points like we did before, A and B. Okay. You can pick another point, P again. So like we did before, so you can see how they all follow on. If we go from A to P to B, okay, right, we create an angle. So we've got that angle there. Oh. Got an angle there. Now, if we then, instead of going to another point on the circle, where do you think we might go to? Well, we'll go from A, actually, to O. Okay? Instead of to another point on the circumference. Right? And we do get another angle here. Okay? Now, the other one that we had before was the two angles would be the same. This case, it's not true though. Any ideas what you think? No ideas? Well, the deal is, whatever angle this one is, so I'm going to call it X, this angle here is double it, so 2x. Well, it will be bigger. It'll be twice as big. Yeah. So, for instance, if I draw another situation, again, center of the circle. This time, maybe make it. See, I call this one. I remember it as the Star Trek rule. And the reason is, if I go from this point into the middle, like that, so I create the bigger of the two angles, and then I go from the same points anywhere else. Do you recognise the symbol? Anyone into Star Trek?
Yeah, it's there you go, symbol.
Yeah. It's delta as well, yeah. And again, this angle is x, this angle is 2x. But what I was showing you is it doesn't actually matter where P is. So for instance, just one more. If I go from this point to the center and then out, if I then went from this point, let's say all the way over here. Now it looks like the other ones, but actually it's not the same as the other ones, because this one here is, compared to that one, this one is x, this one is 2x again. So do you all understand the x and the 2x thing? So if this one was 35 degrees, for instance, this one would be 70 degrees. If this angle here was 110 degrees, this angle would be, careful, knew it, catch up, 55 degrees. If this angle here is 70 degrees, okay, this angle would be 140 degrees. Now obviously my diagram says that's not true, but you know, my diagram is not to scale, and it's not, that is quite a bit. Happy with that one? So whatever you want to call it. Alright. One more, and then we'll get on with some questions. Alright. One more is to do with tangents. So, before you draw, let me explain. So I'm going to pick a point, let's say point P, Do you know what I mean by drawing a tangent? No?
Oh, yeah.
Isn't it the
It's a line.
The line across the circle.
No, it doesn't cross the circle actually.
it
It touches the circle only at one point. Now it's going to be a bit more difficult for me to do. So it doesn't have to be horizontal like this, but I just need it to just touch the circle at that one point. Okay, so that would be the tangent. And what we then do, if we go from that point with the tangent, and we go from there to the centre of the circle, this angle here is 90 degrees. And this is called the normal to the tangent. Okay. And one other thing about it before you draw is if I pick a different point, so let's say I pick this point here, Q, right, and I draw another tangent at Q, so let me just try my best. That's rubbish. Right, so that's about a tangent. Right, now the next part of this is, well, obviously from O to that point again, more right angles, but also this distance here is the same as that distance there. They're equal. Right? So where it crosses there, from here to there, right, is the same as from here to there. So we've got the same thing. Right? So that's another, to do with tangents. Right? So tangents meet at equal distance. Right? So let me draw another.